Good morning, everyone. My name is Russ Kennedy. I'm the Vice President of Product Strategy, Marketing, and Customer Solutions for Cleversafe. Thank you very much for the time today. Thank you for those of you that traveled into Colorado. You got to experience another day of winter in the last week of April. But if you stick around for the rest of the week here, it's going to be summer by Friday. So it changes that rapidly here in Colorado. So we have a very exciting presentation for you today. I have several of my colleagues that are going to help me demonstrate and talk about Cleversafe and our technology. But before I do that, I'm going to give a quick overview of the technology and talk a little bit about a customer case study that we have, so you get a feeling for how our technology is used in the real world. Before I do that, let me just introduce Cleversafe for those of you that have not heard of the company. Cleversafe is an 8-year-old data storage company. We're headquartered in Chicago. We've been building this technology that I'm going to describe since late 2004. We brought it to market commercially in about 2008, 2009 timeframe. It's gone over several iterations and several enhancements, and we'll talk a lot about how the product has evolved since then. We were the first company to bring this technology to market in an enterprise storage system, and I'll describe what it is. It's erasure coding or forward error correction or dispersal as we describe it, and I'll go into details on how that works. But we were the first company to bring the technology to market in a commercial sense. So others have since followed, and there are a number of technologies that are out there that are similar in nature, but we were the first, and we feel like we have the most complete solution. We also have a fair amount of IP patented around this technology as well. We've got over 40 issued patents, and we've got a backlog of about 250 that have been filed that will issue over the next couple of years. So we've patented an immense amount of this technology as we've been building it and developing it. Let me go over the agenda real quick so you have an idea of how we're going to run this day, if I can get the laptop to work. Again, I'll talk about our technology and what is information dispersal, describe it in detail and how it works. I'll go into a quick case study and tell you about a company that we have been using or that has been using our technology for quite a long period of time. That's Shutterfly. How many have heard of Shutterfly? You familiar with that company? So we'll talk about how they came to find Cleversafe and how they've been using that technology. Then we're going to switch, and I'm going to actually have Ramin Rouzbeh, who is our global SE manager, come up and go into a detailed demo on how the technology works. And we're going to be using a live system, so we'll create some storage containers we call vaults. We're going to read and write to those vaults. We're going to take some systems down so you can see the resiliency associated with the product. It is data that's being spread about 8 different sites in the US, so it's all being written live as we go. He's going to show some of the product's resiliency, et cetera, and demonstrate how it works in real life. Okay? Then we're going to switch to Chad Thibodeau. Chad runs our alliances. He's the Director of Technology Alliances. And he's going to come up and talk about a product or a technology we call DSNet Share. DSNet Share is a file sync and share application that works with our object storage system. So he'll demo that, show how that works. And then finally, we'll have Rob McCammon, who is our Director of Product Management, come up and talk about what we call the big elephant in the room, the big data elephant in the room, if you know what I'm talking about, and that is our Hadoop. We call it DSNet Analytics, our technology around Hadoop. So hopefully this will give you a good sense of how our product works, how our technology works, and some real-life use cases for it. I got to be a little bit cognizant of switching screens. So one of the things that's really important when we engage with customers and we talk about the technology and the benefits of Cleversafe is helping them understand to design their systems for failure. Failure happens at all levels. It happens at the individual disk drive or the bits on a platter of disk. It happens at disk drives themselves, and it even happens potentially at locations or sites, et cetera. We engage with customers and we really understand their need for resiliency and reliability of their data as we design a system to meet their requirements. You guys are all familiar with bit error rates on disk drive technology today, and even as drives continue to get larger and larger, we're at 4 terabytes now, we'll be at 5 terabytes next year and going significantly higher. The bit error rates on those disk technologies are not improving. They're staying relatively the same. So the chances of having a failure, a read failure of data that supposedly had been written correctly, is increasing. So what do people do? Well, they use technologies like RAID and stripe data across a number of drives in order to ensure that they don't get stuck into a situation where they can't read the data. But drives fail. And because drives fail, they have to be replaced, and the data has to be rebuilt such that it can be used effectively going forward. So even though people stripe data across multiple disk drives, you still have a chance for failure there. And then people also replicate data or copy data to other sites and other locations, also to protect it. But that potentially could expose a security breach or some level of exposure such that data could be compromised, et cetera. So we talk to our customers about understanding their tolerance for failure and what specifically technologies are out there to address those failure tolerances. One of the things that we're dealing very closely with in most of the customers that we deal with today are at a petabyte or multiple petabytes in terms of capacity. The amount of data that they're storing, the amount of data that they're securing, the amount of data that they're protecting is at a petabyte or growing to a petabyte very rapidly. And as you're all familiar with storage technologies, you know about RAID and RAID technology. It wasn't designed to handle and manage data at that size and that capacity. It's been around for a long period of time. It was working very well, or has been working very well, for smaller data sets and smaller types of files. But when you get to a petabyte or more of capacity, your chances of failure, your chances of losing information go up significantly. It doesn't scale, doesn't meet the needs of most companies that are getting to that level. Cleversafe has taken a different approach. The approach is known quite well in the industry as erasure coding, also known as forward error correction. We call it information dispersal. And I'm going to describe the technology and how it works in this slide, using this slide. Essentially what information dispersal is, it's a way of managing data to tolerate failure of device, to tolerate failure of network, to tolerate failure of security or potential security breach, to tolerate failure of administration. So it's designed to enhance the protection of information to tolerate failure. Essentially what happens when information comes into our storage system, it goes through a transformation process, and that's what forward error correction or erasure coding does. It transforms the data, the bits, into another set of bits. It generates equations, and essentially these equations, just like you remember from your algebra days, are equations that are needing to be solved to get data back in its original form. So it transforms the data, it slices the data up into a number of pieces, it adds a little bit of overhead associated with each piece of data, and then our information dispersal algorithm distributes the data out across a network of what we call storage nodes, a cloud of storage nodes, if you will. And those nodes can be in any site, in any location. They can be spread geographically across a geographic region, as long as you can get to that region over the network. You can write parts of the data, pieces of the data, what we call slices of the data, on individual storage nodes. This example that I'm showing here, we call a 1610. What that means is for each chunk of data that we're storing, we're going to slice it into 16 pieces, transform those slices into virtual information, and then distribute those pieces out over a network of storage nodes. 4 different sites, 4 different storage nodes in each site. The data is engineered in such a way, it's designed and engineered in such a way that you only need any 10 of those pieces at any time to put the data back in its original form. What that means is simultaneously, at the same time, you can lose 6 of anything, because you can lose 6 pieces and yet the data is still recoverable back to its original form. You can lose an entire site, you can lose a site plus 2 nodes, you can lose 6 disk drives, you can lose a network or a piece of your network, and as long as you can get to any 10 of the 16 pieces that you wrote originally, you can get the data back in its original form. So it's like 6x parity versus dual parity or single parity. That kind of idea, okay? When you go to recover the data, the process, the information dispersal process, finds enough of the pieces, the 10 pieces that it needs, and it reconstructs the data back in its original form by solving these equations that were generated when the data was written. As long as it has enough equations and enough of the unknowns, it can match that up, solve the data, put it back in its original form, and then return it back to the application or to the user. That's forward error correction. We call it information dispersal. That's erasure coding. We call it information dispersal. On top of that, what Cleversafe does is we give the users the ability to encrypt the data if they want to. And the encryption process uses random keys that are used to encrypt the data. The keys are actually embedded within the data that is then sliced and dispersed. And what that means is that the data, each individual piece, each individual slice, is cryptographically unusable. You have to have that minimum subset, that in this case 10, in order to get enough information to get the key to decrypt the data to be able to use it. So what that means is that any individual site, if it were compromised for whatever reason, doesn't have enough information to actually go through the decryption process to get the data back in its original form. So it's secure and protected. It's an option that we allow our customers to turn on or enable if they want to. You don't have to use it, but you can, and it guarantees that each individual piece is 100% protected and unusable. One other thing that happens, I'm sorry, did you want to ask a question?
Does that mean you encrypt the key with the key?
The encryption key is actually XOR'd into the data, so it becomes a package, if you will. It's called all or nothing transform, if you've heard of that technology. And the encryption key is actually XOR'd into the data itself. Okay, so then it's sliced and dispersed. So it's part of what's spread out over the network. And so there is no separate key management. It's all built into how the data is managed. The one other thing that I want to describe on this particular chart is what we call the integrity or rebuild process. Constantly in the background, these storage nodes are going through and evaluating the integrity and availability of each individual slice that's been written. And it's all done in the background, and it's all done by the storage nodes themselves, individually.
How does that impact the performance?
It doesn't, because the performance is actually driven, and I'll show you on the next slide, the performance is actually driven through an access layer. There's a device that sits in front of the storage nodes that actually reads and writes the data onto the storage cloud, and it governs the performance of the system. So it does not impact the performance of the system. But it checks the integrity of every individual slice, and if a slice is missing, or a slice is invalid, or a slice is corrupt because of a bit error or something like that, it knows I need to rebuild that slice, and as long as it can get to any 10 of the slices, other slices of that chunk of data, it can rebuild the missing one. So it's constantly rebuilding or generating to full width, what we call full width, which means the data has full integrity. But if something were to fail, if a drive were to fail or a node were to go down, you can tolerate many more failures. In this example, you can tolerate 5 more failures, or if you had 2 failures, you can tolerate 4 more failures before you have to react. So it's not like an emergency when a drive fails or when you have an error corruption. The system detects that, and it rebuilds from the contents of the other slices that are in the system. Okay? Make sense? All right. So then, how is the data ingested into the system, and then how is it retrieved? It's an object storage system. It uses a REST protocol to read and write data onto the storage nodes. We have 2 ways that your application server can actually read and write data. One we call, on the left-hand side of this chart, we call write by name. What that means is that you're going to store the object in that dispersed way that I described, and you're also going to store metadata associated with that object, or a name associated with that object. Both the object and the metadata are sliced and dispersed and spread out across the network. So they have the same level of resiliency and availability. There is no centralized metadata server where all the metadata is kept. It's sliced and dispersed just like the data. We call that write by name. The write process, the REST process, goes through what we call an access device. These access devices, or accessors in our terminology, are stateless devices, but they have a large amount of CPU, they have a fair amount of memory, they have either a 1 gig or a 10 gig interface, or multiple 1 gig or 10 gig interfaces on them, and they run through that dispersal process. They transform data, slice it up, disperse it, or they put data back in its original form. They're completely stateless. There's nothing stored on them. They're just involved in the I/O process or the read-write process. If you need more throughput for your system, you just add more accessors. I'll get to Shutterfly in a second, but they have 65 of the accessors in front of their 70 petabyte storage system. They need more throughput, they just add more accessors. So they all operate independently. Each individual object is unique, and every object has a unique object ID. You can allow us to maintain the metadata associated with that object ID. That's called write by name. If you want to maintain the metadata associated with that object and that object ID, you use the process called write by object ID, and you store the metadata associated with that object in your own metadata database, separately from the storage system. Then when you want to recall that object, you say, give me the contents of this object with this object ID, and Cleversafe goes out, finds all the pieces, all the slices, returns it back into its original form, and returns it back to the application. So you have two ways to do it. You can write by name and store the metadata on the storage system, or you can write by object ID, store the metadata associated with that object separately in another metadata database.
Does that save
Yes.
on performance then when you store the metadata separately?
Yes, it is a faster way to do it. And Shutterfly, I'll get to them, they are using write by object ID. They separate, they keep the metadata associated with the photos that they're storing in a separate metadata database. You can also take that intelligence, the software that does the slicing, dispersing, and retrieval of data, and embed it directly into your application in what we call an embedded client. So if your server, if you want to put the intelligence directly into your server, then you can read and write to the storage system without going through an access layer. You can talk directly to the storage by embedding that intelligence. We sell that as an optional piece, and you can embed that intelligence directly into your application. So we have that process as well.
So
Yes.
You expose the APIs and the client can...
Correct, yes. Yeah, it's a software developer kit. You can understand the APIs and understand the logic, and then just embed that technology directly into your application. Okay? Pure object storage system. If you want to write a different protocol like a CIFS or NFS or some NAS protocol or iSCSI, we have partners that have gateways that we sit in front of our object storage system. We don't have a native CIFS NFS interface or an iSCSI interface on the product today. Purely object storage. Ramin's going to go into this, but this is the installation that we are going to demonstrate in our demo today. This is what we call an 8-wide DSNet. So there's 8 physical servers. Actually, there's multiple, but there's 8 physical servers that we're going to demonstrate, and they're all in these locations. Seattle, San Francisco, Denver, a couple in Dallas, Tampa, New Jersey, Chicago. This is designed, we use it for customer demonstrations, these kinds of demonstrations, customer evaluations. If they want to evaluate our product, we put them on this system. And it's designed in such a way that you can tolerate multiple types of failures. You can see it's on 3 different grids: the Eastern Interconnect, the Texas Interconnect, and the Western Interconnect. If a grid goes down, you still have enough servers to be able to get the data back. It's across multiple different hosting companies: Telex, Equinix, CenturyLink. It's using multiple different bandwidth providers. Again, all to tolerate multiple types of failure. So if any one of those were to go down or go out of business or whatever, your data is still available. And we use that to demonstrate these kinds of capabilities. Ramin's going to go into a lot more detail on it when he shows you the actual live demo. From a marketing perspective, this is what we talk about. Our technology allows you to grow limitlessly from a scale perspective, and actually there is no centralized anything, so it's totally separate from that perspective, and you can continue to scale out your storage, scale out your access nodes, and continue to grow as big as you want. Confidentiality from the all or nothing transform, security and encryption that I talked about, integrity and availability. Again, ensuring that all the data in the system is available, retrievable. If it's not, it's rebuilt all automatically on the fly, getting to 100% availability. Longevity. We've had customers that have had systems, Shutterfly's been running for 3 years now without a failure. They've moved parts of the system all while it's up and running. They've replaced components of the system, storage nodes. They've gone from 2 terabyte drives to 3 terabyte drives and now to 4 terabyte drives, all with the data just being rebuilt on the new technology as they introduce it into the system. Never been down, never had an availability outage of any kind. And we believe because of the use of lower cost, higher capacity, lower power consumption, disk technology, you can actually deploy this for big data storage, large unstructured objects at the most cost-effective point of any storage system that's out on the market today. All right, let me go quickly into the Shutterfly case study, and then I'm going to turn it over to Ramin. So several of you have heard of Shutterfly. Shutterfly is the leading photo sharing service in the market today. They're headquartered in Redwood City, California. They have, I think I have a slide on this, but they have over 20 billion photos, images of individuals, yourselves, your families, et cetera, pictures that you've taken that you want to share with others, or you want to use to generate postcards or calendars or photo books or wedding books or any kind of print of that photo. That's what they do. That's their business. They give away storage for free. You can store as many photos as you want for as long as you want, and they don't charge you a dime on the storage. So it's a total cost for their business. They get no money from that. What they make their money on is when you say, I want to print this. I want to put it on a postcard and mail it to folks, or I want to put it on a calendar book and send it to my family. That's what you pay for. So they're storing these 20 billion images, 70 plus petabytes of data for nothing. So it's a total cost on their business. They were challenged 3 years ago when they first started looking for this technology. They were challenged to reduce the cost of their storage infrastructure by 66%. Take 2/3 of the cost of storage out of their business, because it's key to running their business, but they're making no money on it. So it's just a total cost drain, and they're making no money on it at all. They also had an incident with a RAID system. They had, at the time, they had 20 petabytes of storage on traditional systems, RAID-based traditional systems, and they actually had a failure, actually multiple failures. Over 170 disk drives failed, and they were on pins and needles for several days, thinking, hopefully these things will rebuild before we lose another drive and potentially lose somebody's picture or somebody's image. So they, many years ago, had this issue, had this situation come up, and said, we got to do something different. This is not how we want to run our business. This is not how we want to maintain integrity, nor is this the kind of experience that we want to give to our customers. We want to make sure that we live to our brand promise, which is we will guarantee that your photos will always be available. Again, take 2/3 of the cost out, and they were already getting, at this size, they were already getting very, very good pricing from traditional storage vendors. They were getting, best in class, best pricing from all of the traditional vendors. Still, take 2/3 of the cost out of that. They also wanted to design, again, for graceful failure, for no interruption for their customer, give them the experience that they wanted to give them, and future-proof their storage so that they can continue to grow. They knew their business was going to grow. They knew they wanted to start acquiring other photo sharing services, other assets, et cetera. They knew it was going to grow, and they didn't want to get into a situation where they would be stuck. They couldn't scale or they couldn't grow with a particular storage technology. So these were kind of the design criteria that they were looking at. They actually had a very thorough assessment process. They looked at over 40 different technologies with a very thorough analysis of those 40 different technologies and asked a lot of questions, not just what's the dollar per IOP or the dollar per gigabyte. They asked a number of questions about how the technology would fit into their business and fit into their design criteria that they had mentioned. So they knew they wanted to go in the object direction. They knew they wanted to get to a scalable system that could grow as their business grew. They knew they wanted to deliver the levels of reliability and integrity that they promised their end customers, and they wanted to do it for 2/3 less than what they were paying today. They found Cleversafe at that time. They did a quick evaluation of the Cleversafe technology. Actually, the first system they bought was about a 500 terabyte system. Evaluated it for about 6 weeks, and then the next month went into production, full production. They're now at over 70 petabytes of storage capacity on Cleversafe. They actually designed their own hardware platform, and then we put our software on that hardware platform. So they were looking for a very low cost, very scalable hardware platform that could grow and meet their business requirements. And then they wanted the Cleversafe technology to be able to ensure and deliver the reliability and integrity that they were looking to deliver for their customers. They started with us in late 2010. This is sort of an architectural picture of how their process works. Their subscribers upload photos through their web servers. The photos are then written through a bank of accessors sitting behind a load balancer, so that's all spread out across a number of different storage vaults, what we call storage vaults, and Ramin's going to talk in more detail on what a vault looks like. Their width and threshold, I remember the 1610 that I described before, their width is 26 and their threshold is 20. So they still have a delta of 6, so they can still lose 6 of anything at any point in time. Data is still available. They don't worry about disk drive failures. They replace disk drives once a week. They have disk drive replacement Thursday. Whatever failed from Friday to Thursday gets replaced. So they don't worry about, like they were before, when a drive failed, they had to worry about, can the RAID rebuild fix the integrity of the data before we lose another drive. They don't worry about that at all. They do keep a separate metadata database for all the objects, so all the object IDs go into that metadata database, and then when a user, like yourself or your family, goes in and looks at their albums and says, I want to print these particular images, goes back to the archive, pulls the data out, sends it to a print process or a print job, ships it to your house, and that's how they make their money. Just the kind of the results here, more than 70 petabytes in production, 20 billion images stored. They've acquired a couple of other photo sharing services since they've been working with Cleversafe. The one most recent and the largest was Kodak, so all the assets of Kodak, what was called O-Photo or their Kodak Gallery, about 12 billion, so a little more than half of what was on their original plant has now been integrated into the Cleversafe system. They do on their peaks are the fourth quarter of the year, so from Halloween through Christmas, because that's when everybody takes photos and when they want to share them. They peak at about 50,000 uploads per minute. They measure that. That's their big metric. And the photos are about 3 meg in average size, something like that. So you can kind of do the math and figure out what their I/O workload is in peak. They project to grow to 150 petabytes over the next 2 years. They're at half of that right now. So, and all they are doing is adding storage nodes and accessors to meet that requirement. Their actual cost savings was over 70% from what they were paying before to what the results were from going with Cleversafe. Never lost a photo, never lost anything associated with the system at all, and they don't worry about disk drive failures, storage node failures, et cetera. All the data is available when the customer wants it. Continuing to grow at a 40%, probably higher now because they're acquiring other companies. So very good success story for this kind of technology and a proof that this kind of technology works for these types of applications, big data storage and analytics. Questions on that? Because we're going to transition to the next piece.
I have a weird question.
Go ahead.
This you talked about a customer that has 70 petabytes of data and it will grow up to 150 and so on.
In 2 years.
Do you have a case for the smaller customer possible for your storage? Because you are talking about many petabytes, but actual enterprises haven't.
It's an interesting question, and every day, every year, every month, more and more people reach that petabyte level. When we first started looking at this 4 or 5 years ago, when we first went to market with this, there were very few companies, very few organizations, some government that were at a petabyte and above. Now there's thousands of them. We actually have a database of over 2,000 companies that we know for a fact have at least a petabyte of data. That's who we go after.
So the break-even is 1 petabyte to look at your...
If they're smaller than that, but they're growing rapidly, and they understand the value proposition of this, we're a good fit for them. If they are unstructured objects, they understand the value of an object storage system and the reliability and availability plus multi-site availability that we can bring, it's a good fit for us, and they're growing rapidly. But there's many organizations in the world today that are a petabyte and above. Wasn't the case 4 or 5 years ago. Now it's starting to get there.
Thank you.